Assalamualaikum and good morning to everyone. My name is Abbas Mirusman from this semester DCS 4. I'm studies at IKM Kuala Lumpur and I'm taking course Diploma Komputasi Elektrik PW4. So I want to present about Industrial Revolution IR first until fourth. So enjoy the video. Check it out. Industrial Revolution from IR first until fourth. Industrial revolution in modern history, the process of change from an agrarian and handicraft economy to one dominated by industry and machine manufacturing. This technological change introduced novel ways of working and living, fundamentally transformed society. So, first industrial revolution is started in England in the 18th century, from handicraft to factories, power source, water and steam, overexploitation of workers. Next, industry second. Started around 1870, assembly line and mass production, oil and electricity, efficient electrical machine, less labor force required. Next, industry third. Started around 1970, digitalization and automation, computers, mobile, software, internet. And the last one is robotic. So, the last one is industrial fourth. In progress, complete automation and smart system, IoT, AI, big data, cloud computing, VR, 3D printing, and the last one is focus on sustainability. So, that's all from me for Industrial Revolution from first until fourth. So, next topic is pneumatic and hydraulic. What is pneumatic and hydraulic? Let me show you.
In this video, I discussed the introduction to pneumatic system. Pneumatic system is a power transmission system. Okay, means it transmits the power, in which transmission of power takes place through compressed air. So by using the compressed air, we transmit the power. This system is called as the pneumatic system. Okay, so such a system in which power is transmitted by the compressed air or a compressed gas, it's called as the pneumatic system. For compressing the air, we require the compressor. Means mechanical energy is given to compressor, and that is the mechanical energy, means it is a shaft power. Okay, so shaft is rotated. So shaft of compressor is rotated by means of any prime mover. Prime mover means any electric motors, IC engines are used as a prime movers, or a turbine is used as a prime movers. So here you see this is the compressor, and in compressor we supply the mechanical energy, and this mechanical energy is produced by using the prime movers. Okay, so whatever the primary thing supplied to the compressor is the mechanical energy. Okay, so either this mechanical energy is generated by electric motor or either a IC engines. Mechanical energy means that is the rotations of compressor shaft. Now compressor draw the air from the atmosphere and compress the air and flow to actuators through pipes and valves. Means compressed air is supplied to the actuators. So in between the compressors and actuators there is a pipe connections and the valve connections is there. So after the rotations of the compressor start, it's draw the air inside the compressors and it's increase the pressure of the compressed air, and this compressed air is passed through the different pipes and valves, then it is supplied to the actuators. So here you see this compressed air, means in a compressed air that is a flow of energy through pipe, valves, it's supplied to the actuators. Actuators produce back the mechanical energy, means this pneumatic energy, means pressure energy of the compressed air is again converted into the mechanical energy. Okay, and this mechanical energy is either in a linear motions of the cylinders or a rotary motions of the air motor shaft. Okay, so it is depending on the requirement. Okay, but actuator is produce the mechanical energy. So here our output is mechanical energy and also the input is the mechanical energy. Okay, but in between they are produce some force and they do some work done.
So that's about pneumatic. And what's about hydraulic? Let me show you this video.
Hydraulic jack. How it works. A hydraulic jack is a mechanical lifting device used to apply great forces or lift heavy loads. This jack uses hydraulic power. The most common form is a car jack or pedal jack, which lifts vehicles so that maintenance can be performed. The more than tenfold increase in force produced by the hydraulic jack is sustained by the hydraulic lever principle. Let's try to understand how a hydraulic jack works, taking the bottle jack as an example. Lever 1 is positioned in such a way that the arm between the pump's plunger and the axis is smaller than the arm between the axis and the handle to which the force is applied. In this case, the mechanical lever principle is utilized, which allows to magnify the applied force several times. With the help of a mechanical lever, a force is applied to the small piston, making it move downwards. The pressure under the piston will be calculated as the ratio of this force to the area of the surface of the piston. According to the laws of hydrostatics, the pressure applied to the surface of a liquid is transmitted equally in all directions to all points of this liquid. This means that the same pressure will act on the large piston. The pressure on the both pistons is the same, but the area of the surface of the larger piston is larger. Therefore, it can assume a larger force. The larger the area of piston 2 and the smaller the area of piston 1, the greater the amplification factor can be obtained by using the hydraulic levers. The total displacement of the large piston will depend on the volume of fluid displaced by the small piston. The area of the surface of the second piston is larger. Therefore, the distance it is displaced by will be less than the distance that the first piston was displaced by. It follows that the hydraulic lever allows you to increase the force you apply to it. But at the same time, the movement of the larger piston is very small. To move the large piston further, a new portion of the fluid is necessary. But where does one get it? Let us add a tank and 2 check valves to our device. The check valves allow fluid to flow in one direction and do not allow it to flow in the opposite direction. Now, when we pull the handle upwards, the small piston will move upwards as well. The volume of the space underneath will begin to increase and the pressure will drop. Valve 1 will let fluid out of the tank and into the space under the small piston. Valve 2 is installed in such a way that it does not allow fluid to flow out from its place under piston 2. When the small piston reaches the top, we will begin to put pressure on the lever again. Valve 1 will not let fluid into the tank, and the valve 2 will allow fluid from under the small piston to flow into the space under the large piston, which will move up a little more. This cycle can be repeated many times. The lever is moved up and cavity under the pump's plunger is filled. The lever is moved down and the liquid is forced out into the space under the large plunger. If the load needs to be lowered, the release valve is opened and the large plunger moves downward under the effect of the load's mass, while the liquid from under it goes into the tank.
Okay guys, that's all from me. Thank you and please like this video. Bye.